All right. So just let me know when I can start the workshop part.
Yes, sir. So shall I start?
Yes, you can
Okay, sir. Good afternoon, everyone. Happily welcome you all for the fourth day PDP National Program of Resource Person of Dr. Arun Mittal. This session is yours. You can take over, sir.
Thank you.
Thank you.
Thank you for connecting me with the audience. So now we have discussed so far what is how do we fill the data into SPSS and how do we apply certain basic statistical techniques such as t-test and ANOVA. Yesterday we also saw about two-way ANOVA after one-way ANOVA, and then we prepared a table that which statistical tools we can use in which conditions and situations. Now I'm in process of making some very useful videos for my audience on this also, that which statistical tool we can use in a particular situation, particular type of nature of data with examples. Yesterday I shared the link of my YouTube channel along with the factor analysis video. So I requested that you should just go through that video so that understanding of factor analysis is easier for you. Now, when we talk about factor analysis or exploratory analysis, it is very popular, and today's session is very important for all of us. The factor analysis or exploratory factor analysis is a technique which is extremely popular in the research papers, in the research projects of the MBA or graduation and post-graduation students. So we will first try to just let me know if my voice is not clear or any interruption in between. And what is the reliability and validity concerns? What should be the sample size? What next once we have applied the factor analysis and so on. Okay. Now I will share the screen and I will start discussing upon the factor analysis introduction, and then we will take a practical example and we'll understand the whole part. So now let us see. So I have shared the screen and I'm just typing here some notes about the introduction of exploratory factor analysis. So exploratory factor analysis is popularly known as factor analysis, but factor analysis has two parts, two types. So I should write it like this: factor analysis. Now, first is exploratory factor analysis, and second is confirmatory factor analysis. These are two types of factor analysis that are very popular in research. We will do exploratory factor analysis. Okay. Before we go ahead with exploratory factor analysis, let us understand what is the difference between exploratory and confirmatory. So as the name suggests, it explores and it confirms. The first one explores and second one confirms. In exploratory factor analysis, we do not have no fixed constructs or variables. Now, this term will come again and again. When we discuss about factor analysis, the terms variable, component, construct, item, statements will come again and again. So to be comfortable, we make a table, okay, and understand when we say variable, we say it is manifest variable. So variable manifest variable, item, statement. These four are one and the same thing. But when we say construct, say factor, latent variable, component, and construct. Okay. This is one and the same thing. Okay. These four same, these four same. Now, important thing is, why do we use the term manifest variable? So manifest variable is basically the variable which can be measured directly, and latent variable is the variable that is measured with the help of manifest variable. So suppose we want to measure the happiness. So I want to measure happiness, but I say that happiness cannot be measured directly. It is a latent variable. I want to measure your happiness. I make a scale. I make 4 statements which are very similar to each other. Okay. So my first statement is, I am happy today. Okay. And I wanted you to rate it at some Likert scale, 4, 3, 4, 3, 2, 1. This is an interval scale. But factor analysis always work on a Likert scale. Now, Likert scale is, lot of people do not understand the meaning of Likert scale. Every interval scale is not Likert scale. Likert scale means asking the respondent similar statements time and again to establish the reliability of the scale. So I say reliability. Now, what is reliability? I'll come to it later, and we will numerically test it also. Just anyone please confirm I am audible also and my screen is visible. Can anyone confirm?
Yes, visible, sir.
Thank you. Thank you. So every interval scale is not Likert scale. If these statements are not similar to each other, it is not Likert scale. So I am happy today. The second statement is, I feel good and positive. I feel good today. Good today. I am positive. Life is beautiful. To me, life is beautiful. So if a person is happy, he'll be very positive. He'll be talking about good about life. So if there is a correlation among all these statements, it means that my statements are correct. I am able to measure correctly, isn't it? If I write here, I have lot of money, right? So this statement may not correlate with other 4 statements. Money is a different thing. Happiness may be a different thing. One may have lot of money, but one may not be happy. Okay. I have seen a lot of people who have lot of money, but they're not happy. So probably this statement will be an odd one out, or it will not be correlated highly with the other statements. So I'm using the word here, statement. Statement is the latent, the manifest variable. So happiness is a latent variable. Statement 1, 2, 3, 4, 5. These are the manifest variable. Okay. So happiness latent variable is measured through the manifest variables as below. All right. Now happiness is not measured. The statements have been measured. Okay. Factor analysis actually helps us out to establish the reliability of a measurement scale. Measurement scale means a group of statements. Okay. So suppose I have worked out upon, there is an example, classical example given in my videos. I have developed that example on. Okay. Anyways, let us make one more table and write here exploratory factor analysis. Okay. And confirmatory factor analysis. Right. Now, when we apply an exploratory factor analysis, we want to explore the variables. Sorry, factors. I don't know, suppose I have, say, 20 variables. Maybe I come with 4 factors, 5 factors. So, in the beginning of this, the factors are earlier unknown. Factors are unidentified. They are not identified. We identify them when we apply this factor analysis. Okay. Factors have been already identified. Factors have been already identified. Okay. And we apply factor analysis to CFA confirms the factors. Broadly, CFA confirms that you have done a great job. Now, what are the outcomes? KMO. KMO stands for checks the sample adequacy, whether the sample is adequate or not for applying the exploratory factor analysis. Right? What other outcome? Cronbach's alpha, we can calculate, that is for reliability. Okay. Then we receive what? Factor loading. So factor loading means the correlation between factor and statement or item. Factor and item correlation. This should be, now I can even write the values, we will come later when we will apply it. Okay. These are the outcomes, and main purpose is to explore the factors. This is the main purpose. So this purpose is fulfilled. The main purpose of CFA is to confirm the factors, model fit and validity, as well as reliability. So we check the reliability with the help of Cronbach's alpha in exploratory factor analysis, but in case of CFA, the reliability is checked with one other more measure, and validity is also checked. So what are the outcomes of CFA, confirmatory factor analysis? Now see, factors have already been prepared by exploratory. So confirmatory does what? Model fit. Whether the scale has good model fit or not. So in model fit, there are certain parameters we need not discuss because this is not part of our syllabus. After model fit, we check the reliability with the help of CR, that is composite reliability, and AVE and MSV. These are some measures, you need not worry about them. Just I'm telling you, and then you check the validity. There are 2 types of validity. You check with the help of Cronbach's, you check discriminant validity and convergent validity. So these 2 validity we check. Now, having done all this, we move to the structural equation modeling later. and the purpose is model fit and everything. So once this is done, our model is confirmed, then we go for the causal relationships, which is structural equation modeling. So I can write next step after CFA is structural equation modeling, SEM, okay, which is again very popular in the research papers. Now coming back to exploratory factor analysis, we need what? We need a questionnaire or a scale on which we can apply the factor analysis. The whole game is of correlation. Correlation among the statements or items or manifest variable or variable, whatever you call. Based on correlation, they will be grouped together. So we are making the group of the statements which are similar to each other. I will open a questionnaire. Okay. And suppose this questionnaire, I don't know what group will be there. So this questionnaire is liking and purchase intention for tea, a scale development study. I want to develop a scale wherein I'm asking people that whether they like tea or not. Okay. Whether they like tea or not. If they like tea, whether they purchase or whether they are fond of tea or not. Okay. So I made some statements upon strongly agree to strongly disagree, and the scale is, I have the data file as well. This is the data that has been collected for 11 statements. 11 statements, okay? And the data is on 7-point scale, 7-point Likert scale. So this is from, so strongly agreed is 7, then 6, 5, 4, 3, 2. So you created, you get the things. So the statement is, I like tea. I feel pleased when someone offers me tea. I take tea regularly. Taking tea is an essential component of my routine. I do not have any control of the number of cups of tea. I do not care much about cost of tea. I do not check the price and compare while buying tea. I can pay extra for better quality of tea. I generally purchase tea from the market. So generally I purchase tea. It should be generally I myself purchase tea from the market. Purchasing tea is a routine buying for me. Tea is generally on my grocery shopping list. Now, if I ask anyone to divide these 11 or find the similarity. So I see that I like tea. I feel pleased when someone offers me tea. So this is also liking. I take tea regularly. This is a consumption. This is liking. This is consumption. So consumption is also an outcome of liking. Taking tea is an essential component, and that is what I like tea, and it is an essential component. I do not have any control over number of teas. It means I like tea very much, so I don't have any control. This is a very strong aspect of liking. These are normal aspects of liking, good aspect, but this is very strong. All right, just all right. So So I can put these 5 in one basket, like I'm not doing it. The data will do it for me. So I need not worry about that. I do not care much about the cost of tea. So cost, price, and paying extra. Somewhere these 4 are related to each other. Somewhere these 3 are related to each other. I don't know what will happen with the data. Generally, this is purchasing, basically related to purchase. Okay. So this is what the kind of segregation, kind of classification and clubbing or grouping of data factor analysis can do. I don't know, this is my guess. Whatever I have done, I will apply the statistical tool, which is factor analysis, and then we will discuss further. So let's go to the data. Now, this data is for statement 1. Statement 1 means this one, I like tea. This data is for statement 2, column 2, statement 2. Statement and variable, one and the same thing. So variable 1, variable 2, variable 3, and variable 11. Okay. This is just a coding. A1, A2, A3, A4. This is just coding. After coding, after doing this, let us see what is the length of the file. 372. Okay, no problem. Now we will apply factor analysis. One more important aspect of factor analysis, applying factor analysis, is if we apply factor analysis, this is the first step of development of a scale. So we can develop a scale if we apply factor analysis. All right. Not only factor analysis is one thing. For scale development, we will have to apply factor analysis, confirmatory factor analysis, and structural equation modeling for nomological validity. One more is nomological validity, which is checked by SEM, structural equation modeling. But now I'm going back to EFA. Only this. We are studying only this. So let us apply EFA. We will go to analyze. In analyze, we have dimension reduction. Why we call it dimension reduction? Because it reduces the huge number of variables into small clusters, small cluster of variables. Like we have 11, it may reduce in 3 factors. Okay. If we may have 40, 50, 60, depending upon the correlation among the variables, it will do this particular help for us. So far, any questions or any doubts you can ask. So all clear, all right?
Yes, sir. Yes, sir. There is no any doubt.
Thank you. So in dimension reduction, we have factor. So we click on factor. We have 11 factors here. So 11 we can insert all 11 in one go. So we have many options on the right hand side, like descriptives. In descriptives, we need to check initial solution is by default checked. We need to check KMO. Okay. Continue. Then we click on extraction. By default, extraction is principal component. There are many other options, but principal component is the most popular. We have based on eigenvalues. So based on eigenvalues, I will do all the calculations for you today so that exploratory factor analysis is absolutely clear. So I will tell you how we calculate eigenvalues. Eigenvalue 1 is by default, iterations 25 by default. You can take a scree plot. It's a graphical presentation of eigenvalues. You can take it and continue. Rotation is very important. By default, it is none. We take Varimax rotation. Two rotations are very popular, Varimax and Promax. Some people take Promax, some people take Varimax. There is no big difference. Varimax is more popular. Continue. Then scores. Right now, I'm not saving any scores, so I'll leave it and then click OK. So we will get a whole basket of, I think in options, I forgot something. I will not forget, but I will let you know. Okay. So I will take a one by one, the useful tables only. First table I take is KMO and Bartlett test of sphericity. The value should be more than 0.65, which is recommended. If it is less than 0.65, you should not go ahead with the factor analysis. So more than KMO should be, you will find a lot of books and other people saying that it should be above 0.5. See, above 0.5 is poor and below 0.5 is not acceptable. But above 0.5 does not mean it is good. It is very poor. It means you should do not go ahead with the analysis. At least it should be 0.65 or more. Okay. The significance should be, this should be significant. It is below 0.05. Below 0.05, then we call it significant or good to go. So there is enough variability, enough variation in the data. The matrix is not identity matrix, and this is good to go. So KMO and Bartlett test is the initial qualifier of factor analysis. If they are good, then we should apply factor analysis, otherwise we should not. So we fulfill both the requirements, so we can go ahead with the factor analysis. Okay. Now you see what is the next table, which is useful for us. Communalities. Now communalities show something that we'll discuss again later, but I'll tell you the communality value should be minimum 0.4. If it is 0.5, it is good, but it should be minimum 0.4. Below 3 is not at all allowed. Now, this table, variable number 5 is giving a communality value which is very close to 4. Not 5, not 3, but very close to 4. This may not be a very good statement to be go with in the factor analysis. Okay. So we should take care of it, that if it is 0.5, then we should be happy enough. But if it is below 0.5, we may drop. See, in exploratory factor analysis, the biggest benefit is you can drop the statement. Nobody would ask you that why you have dropped, because we are just exploring. We are saying that this statement is not fitting into the scale. We are dropping it because these 4 statements are good, so that we can measure the things further. So we are developing a scale. So no problem at all. Okay. Next we go to the next table, which is total variance explained. Okay. Now this table will show us how many factors have been extracted by the factor analysis. So now this table fits to the Word file. Well, let us see this table very carefully. Many times people say that the data is missing. The data is not missing here. This data is automatically suppressed by the software, where the eigenvalue, these are the eigenvalues. It is written here, initial eigenvalues. It is 1 till 3. There are 3 factors. Okay, better I mark them red. Now, this eigenvalue is 5.085, 2.046, 1.176, and when it reduces below 1, there is no need to show the values. Okay, so 3 factor explains 75.513% of the variance. We can say 3 factors explain this percent of the variation. This should be minimum 60%, and some of the authors have suggested 66%. So ours is 75%. It means it is quite good. It is quite good. Okay. So we can go ahead with the results. The results are good. All right. Now, what is this variance, variation, all this rotation, extraction? We should need not go into much depth, but I will tell you. When we apply rotated component matrix, it gives a chance to all the factors for further permutations and combinations to find out the consistency in the percentage. So you see that earlier first factor was explaining 46%. Now first is explaining 26, 24, 24. So almost similar. Generally, we do not report these 3 columns. We report only last one. Okay. Now, what is the next part of the analysis? The last and the most important one is we can leave scree plot. It is graphical representation of eigenvalues. First eigenvalue is 5 point something, then 2, then 1, like that. Then we go to rotated component matrix. There are 2 component matrix. One is component matrix, other is rotated component matrix. So we copy the rotated component matrix, paste it here. Now, rotated component matrix is I will show you another rotated component matrix, but let us understand it. If I see a pattern in the column 1, so I find a pattern of 0.6, 0.8, 0.7, 0.8, 0.5, 0.0, 0.0, 0.1, 0.2, 0.1, 0.2. These values are very less, okay, and these values are high. So I make one cluster, one correlation of, because this is called factor loading. This value is the values given in this table, factor loading. Factor loading should be, then there are different rules. Good factor loading is more than 5, 0.5. Okay. So we'll take a test of it as well. Now, in the second factor, till this point, the values are low, but this is 0.332, but otherwise the values are low. From 0.9, 0.9, 0.8, these three values are quite good. So this becomes one factor. These are also low, so I'm cutting them off. Here, these values are low, below 0.5, and these values are above 0.5. Okay. So you can see that all 11 statements have been divided into three factors based on the rotated component matrix. Okay. So am I clear? All right. Now there is another method, not a method, just a setting in the software that I can get this result at one glance. So what I do is, while applying the factor analysis in the options tab, I click on suppress small coefficients. In suppress small coefficient, I can write 0.5. So if some factor loading, which is below 0.5, can be suppressed. So click continue. This will calculate the whole thing again, and then it will give a table which is rotated component matrix like this. All right. So now this table is absolutely clear because it has suppressed the variables that are. Now, one item is still on our mind, which has 0.5343, which is a poor, not poor, but lesser, factor loading. So what to do? We will see it later. Okay. We will see it later. What else now? Now, the challenge is sorry. What else to be calculated to confirm that, to check the reliability of these factors? We have three factors. Okay. First factor is made up of these 5. Second is made up of these 3, and third is made up of these 3. We have to name them, but before we name, we first check the reliability. So how do we check the reliability? We check reliability with the help of Cronbach's alpha. Cronbach's alpha. Cronbach's alpha is the measure of reliability. We check the reliability factor wise, like 1, 1, 2, 3, 4, 5. Factor 1. Factor 1. Factor 2 is 6, 7, and 8. And factor 3 is 9, 10, and 11. Am I right? All right. So we have this factor-wise reliability needs to be checked. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if you want to check the reliability, there is a test in analyze scale. Under scale, you have reliability analysis. So in reliability analysis, we will apply, by default, there is alpha, split half, Gutman, parallel, strict parallel. So we apply alpha. Alpha is the Cronbach's alpha that we use to check the reliability. First 5 variables we put inside because these first 5 belongs to factor 1. Okay. The Cronbach alpha value for factor 1 is 0.826. 0.826. We can see here Cronbach alpha is 0.826. Number of items are 5. 1, 2, 3, 4, 5. The Cronbach alpha should be more than 0.7. Okay. So we fulfill the requirement of reliability. We can say that our first factor is reliable. All right. Factor number 2, second factor. 6, 7, and 8. I again go to the SPSS. Okay. 0.926. All right. 9, 10, and 11. 0.898. So it is 0.898. This is the reliability. You want to paste the file, you can paste the table. All right. Now you see that we have got the reliability, which is a good. Out of 3, factor 1 has a little lower reliability, but it is above the threshold. Every now and then the culprit is the statement number 5. Now it is up to me whether I want to keep this statement or I want to drop this statement. There is one more diagnosis. If you are in a doubt, we check the reliability of the entire scale also, all the statements. Overall reliability is coming 0.880. 0.80. Okay. 0.880. Now, when the overall reliability is 0.880, what is the purpose of it and where this statement number 5 is to be tested? So there is one more diagnosis in factor analysis in reliability. Under statistics, we go for scale if item is deleted. Okay. Scale if item is deleted. If I delete an item, what will be my reliability? Whether it improves or it doesn't improve. If it improves, I can think of dropping that statement. Okay. Or item. Statement and item, one and the same thing. All right. So let's see. Continue. Okay. I kind of a schedule like this. Scale if item is deleted. If I delete, what is my total reliability, overall reliability? 0.880. Okay. If I somewhere find more than this, then I should be attracted. So I find more than this here, 0.882 and 0.88, 0.882 only. Okay. So if I delete A5, my overall reliability would increase 0.882, only 0.002, but it will improve. Okay. Dear listeners, so most important thing is the factor loading of 0.543 is not enough, not very good, if we want to apply the confirmatory factor analysis. Why? Because confirmatory factor analysis is even a more strict tool. So either you drop A5 here or you can drop it there also. You can drop it later also, not a problem. If the time will permit, I will show you how these confirmatory factor analysis. And why I'm saying that this is a problem. Okay. So we may delete it or we may not delete it. Let us move further on the next part. Naming the factors. Okay. Now, if I go to the questionnaire back, how would I name the factor first? I think I should use dark colors. So first factor is like the field, please. So basically it is more about liking for T. So I can say my first factor is liking for T. Factor 2 is cost concern, whether I am concerned for cost or not. Or I can even write it no cost concern, that I don't have any cost concerns. And factor 3 is actual purchase or purchase intention or purchase behavior. Okay. Since behavior is a very broad term, so we can use purchase intention or purchase pattern or something similar to. Okay. Now, we see that can say purchase pattern, we can say purchase behavior. That's fine. Fine for now. Now, liking for T, no cost concern, and purchase behavior. If I ask you, any one of you, I don't know how many of you are directly connected with me and how many of you are indirectly connected. If I need to segregate independent and dependent variable, which will be my dependent and which will be my independent variable? Anybody who wants to try, who are in the meeting or listening to the session, which out of these two should be the dependent variable and which should be the independent variable? Anybody? Okay, fine. So suppose in a normal way, in a normal sense, we see that behavior is generally a dependent variable and it is affected by wide variety of factors. Suppose liking for T, no cost, liking. Okay. So let me make it a neutral one, cost concern, whether it is positive or negative. So I can say that liking for T and cost concern, liking for TF influences the purchase behavior. Okay. Cost concern influences the purchase behavior. Now it doesn't matter for me. This statement doesn't matter for me. The group of statements matter for me. Okay. So which statistical tool I can apply on these two hypotheses These are hypotheses, but alternate hypotheses, HA1 and HA2. Okay. These are the hypotheses that, that matters. And for me, it is important to prove, to check whether these two hypotheses can be, they are significant or insignificant, but I'll do it later. Here it is important that how do we, because for this we need the value of all three, factors, the columns in the SPSS file. We need it or not? Yes, we need it. But do we have? No. We have the value of all these statements. The first is made by these 5, second is made by these 3, and third is made by these 3. So one way to do it is average of 1, 2, 3, 4, 5 for factor 1, average of 5, 6, 7, 8 for factor 2, average of 9, 10, and 11 for factor 3. This is one way to go. This is one way to do it. All right. But what is the other way to do it? The other way to do it is, this is first, very important. Are you with me? I cannot see that window. Participant, yes. Gayatri, ma'am, Nitya, and Anai, the host. Okay. All right, no problem. Now, you see that this is method 1. What is the method 2? Method 2 is factor scores. Save the factor scores while applying factor analysis. Okay, we save the factor score while applying the factor analysis. All right. Second. And third is use imputed values. Imputed values. And for that, we require confirmatory factor analysis. So basically, these first two are possible after factor analysis, and third is possible only when we apply the confirmatory factor analysis. Okay. And let us go further. We will take up the second one. Second approach is scientifically considered to be the second best approach. This is the best approach. Third is the best approach. Okay. Best. And this is the second best while applying any hypothesis testing, regression kind of thing. So what we will apply here, we will apply multiple regression. Okay. For multiple regression, we need the value of these 3 variables. Okay. So what we'll do is we will apply the factor analysis again. Analyze. I can take it from here also. Factor analysis. Okay. And in the scores, I click on save as variables, that is regression. Okay. Continue and okay. Rest everything will remain same. Now the output is of no use for me. I can simply cross it. Okay. I go to the input sheet and find 3 new columns which have been saved by factor analysis for me. Fact1 underscore 1, fact2 underscore 1, fact3 underscore 1. So these are basically representing these are the Z score values. So you can see some minus, plus and all. So no worries, no issues. Factor 1, factor 2, factor 3. These factors are completely uncorrelated with each other. They are not correlated to each other. That is the requirement of factor analysis. They are not correlated. So if you apply, say, correlation, bivariate correlation of these 3 factors, fact 1, 2, 3, your output shows that there is Pearson correlation 0 and 0, 0 and 0, 0 and 0. So there is a 0 correlation among the factors. Okay. So you can write here also 0 correlation factors. Now the problem is, if there is 0 correlation, then 0 regression and 0 relationship. So this is the biggest shortcoming with the factor scores, that all dependent and independent cannot be factor score. Okay, there should be one which is not a factor score, which is an average. So we have to calculate the average of the dependent variable. Okay. So let us take average in case of any. Let's take the average by applying the transform compute variable. We are computing a variable with dv, dependent variable, made up of 9, 10 and 11. So we see we can take something from here also, and we can do it manually also. So plus and plus, adding these 3 and dividing this by 3. Okay, simply press OK. So there is one more variable generated here as dv, which is the average. So one variable which is dependent variable should always be an average or a imputed value. Factor score will not work because factor scores have 0 correlation. Okay. Now, before we apply the factor analysis, I would like to show you something. I earlier mentioned that the factor loading. Where is factor loading? This is factor loading. So can you see this this 1 and A1 and 0.651? Now, what I want to say is that 0.651 is the correlation between factor 1 and statement 1. Oh, okay. This factor score first factor and first thing. This is what I am saying. So let us prove it. Let us try to do it. In the input file, we go to analyze. In analyze, we go to correlate, bivariate. So this is the factor. This is the item. Let us calculate their correlation and copy, say paste. This is 0.651. Okay, this is also 0.65. So this says that the factor loading is the correlation between what? Correlation between factor and state. Okay, okay, clear. So any questions, any doubts so far? Anyone who wants to ask anything? Anybody who wants to? I cannot see any doubts on chat, but
Sir, there is no any doubt, sir.
okay.
Because the session is
So
here only for us, sir. Thank you for the session, sir.
sorry.
No, sir, there is no any doubt.
Okay, so we will continue today till 4. Okay.
Sir, can you please repeat that?
Can we continue till 4 o'clock? 4 p.m. today?
Sir, yes, sir. Either we can wind up by 3:45, sir.
Okay, 3:45 is okay. We can wind
Okay,
up.
thank you, sir.
Yeah. All right. So, right. So factor analysis, the major portion, major part we have completed. But alone factor analysis sometimes not help out while writing the research papers or while we are, discussing on uh, many other things or we are presenting our findings. All right. So this is what I have shown you a lot of calculations, but step by step you will have to explain them in a research paper. More important is the regression analysis, and we would like to find out the impact of one on the other. If I go to my original questionnaire and the hypothesis I set up, these are the hypotheses I set. So I'm just cutting these two hypotheses from here, putting them down here. Okay. Now I would apply what regression analysis, and we'll find out that how regression analysis affects the how regression analysis gives me the results that liking of T influences the purchase behavior and cost concern influences the purchase behavior. So I write here the so I go to analyze in regression, linear regression. Okay. Now in linear regression, I have factors. Dependent is DV, factor 1 and factor 2. Factor 3 we will not take because factor 3 is a DV and we have a different calculation for DV. The by default method is enter method and I click OK. So I will not explain the results of regression analysis in detail here, but I will take it the main part, main analysis. Copy it and paste it here. Okay. Only coefficient table, and let me change the names for better understanding. Independent variable 1 was liking for T. Independent variable 2 was cost concern, and the dependent variable was purchase behavior. Okay. So these are the three variables. Forget each and everything and come to the significance. This first is intercept. Intercept should be significant. It is there. Liking for T is significant because significant impact means the value of significance, P value, is more than, sorry, less than 0.05. Okay, so it is 0.000000. This is not actually 000. We show it like it. It is not 000. So we always write it is less than 0.05. Let me show you. It is never 0. If I double click on this, you see that there is a value 0.00013. Let me see. I copy this. Since I have suppressed it to certain, see, this is the value actually. So never write that p value is 0.000. Always write that p value is less than 0.05. Okay, that's very important. Clear? So both are significant. So we derive a conclusion that purchase behavior for T is significantly influenced by liking for T and cost concern. Okay, liking for T and cost concern. Clear? Any? So this is the way that we get the benefit from the factor analysis. Rather than writing here 11 statements, I compress it in 2 or 3 statements, 2 or 3 variables, and then I can go ahead with the causal relationship or causal analysis also. Okay, so we'll take a quick recap of whatever all we have done in the factor analysis. First of all, we should have a questionnaire with the similar statements. So I want to measure something. I want to be sure. See, I cannot go to a respondent today, tomorrow, and day after tomorrow to ask the same thing. So Likert said, don't ask the same thing on different intervals. Rather, ask similar thing at the same time. Like if somebody, suppose you want to check whether a person is good at mathematics or likes mathematics, so you can ask, I like numbers. I always enjoyed maths classes. Okay. I devote more time in studying maths as compared to other subjects. I am not scared of maths. So basically, you make some similar statements like this, and that helps you out in. I have hundreds of such questionnaires in which the similar statements are prepared or I guided people to prepare to get good results. Okay. And then we apply the factor analysis, and factor analysis gives you good results. One more aspect is factor analysis is base for cluster analysis also. Like when you want to apply cluster analysis, you apply cluster analysis, you go for factor analysis also. And you will find that factor analysis gives you crisp factors, and based on that you can do the clustering. Okay. What is the difference between factor analysis? Basically combines the variables or groups the variables cluster analysis groups the respondents, not the variables. Respondents or people, customers, or employees. So it is the most important application is market segmentation. Okay, we use it in market segmentation. All right, so these are some of the applications of factor analysis. We will discuss one more application later, which is removing multicollinearity. Removing the multicollinearity. That is also one very important feature of factor analysis. Multicollinearity means high degree correlation between the independent variables. Okay, so we had two independent variables like liking of tea and cost concern. Now these are the outcomes of factor analysis. So there is no multicollinearity. We check that there is a zero correlation between these two. And this is the requirement of regression analysis. Okay, so which is a multicollinearity, no multicollinearity requirement. There should not be any multicollinearity if we want to apply the regression analysis. Okay. So this is I know that it is little difficult for the beginners because factor analysis is a little vast topic having many different statistical techniques, small techniques. But I think I could add a value to your existing knowledge, and you can have as many questions as you can ask, or maybe you can route through WhatsApp or any other means. And if you request me to make videos specifically on any topic, I'm always ready to do that. It's not a problem. So with your permission, with your consent, I would like to wind up here for today. And tomorrow we will take up the new topics which are, left with us. So let's meet tomorrow. Okay, ma'am. Shall we wind up? So we have the topic for tomorrow. We have multiple regression. So we'll discuss it thoroughly, multicollinearity and stepwise regression. Absolutely fine. So tomorrow we'll discuss this, and then cluster, and then research paper writing. I think
Okay, sir.
has been beautifully designed. Okay. So, all right, then we'll wind up here. Thank you. Thank you.
Thank you, sir. Thank you for the informative and effective session. Once again, thank you. We expect tomorrow we will more effective, sir. Thank you, sir.
Thank you so much. Thank you. Bye bye. Thank you.
என்ன